The last thing that we're going to deal with is dilutions. Okay, what does it mean to dilute something? Yeah, we want to decrease the concentration, right? In other words, in very simpler words, what are we doing?
Adding more solvent.
Yeah, adding more solvent or watering it down, right? That's what comes to mind, right? We're watering it down. So we're talking about how much does it take of a really concentrated solution to make a diluted solution. Okay, and we're going to watch a little video that shows you how to do that. But this is the equation that goes with the dilution. C1 times V1 equals C2 times V2. What do you think this C stands for? Yeah, it stands for concentration. And what do you think V stands for? Volume. Okay? So volume is always going to be measured in liters most of the time, or milliliters, it could be. But concentration is always going to be measured in molarity. Okay, concentration is always measured in molarity in this equation. So sometimes you'll even see it written as this, M1V1 equals M2V2. Okay, and the only difference there is that this one is molarity, it stands for concentration. They're the same thing. Okay, but I'll always write it as C1V1 equals C2V2. Okay, so concentration changes. So we're talking, how much of the concentrated solution does it take to make a dilute solution of whatever? Okay? So let's try one here. Okay, let's say I have, if I dilute 175 milliliters of a 1.6 molar solution to 1.0 liters, what is the new concentration?
Yeah, put the volume meters. I would just like the gas laws.
You can keep, yeah, I would usually put it in liters, yeah. It's not going to make a huge difference, but yeah, I would usually put it in liters. They have to be the same, though. That's important.
Did you just solve this like I did the gas laws?
Yep, salt, just like you did the gas laws. When in this situation, see how we have milliliters on one side and liters on the other? You have to be consistent. So most of the time I'll pick liters, right? Take them all to liters, but you do have to be consistent there. So we're starting with 175 milliliters of a 1.6 molar solution, and we're basically going to fill it up until we get to 1 liter of our solution total. So do you expect the concentration to go up or to go down?
Down.
Down, right? We're adding water until we get to 1 liter of our solution. We're not adding any of our substance. We're just adding water until we get up to 1 liter. So that means we would expect our concentration to go down. Right, so C1 times V1, 0.175 equals C2, which is what we're solving for, times V2. Okay, and what did we get our concentration to come out at? 0.28 molar. Good, got to have that unit on there. 0.28 molar. Okay. Calculate the volume in milliliters of a 18.1 molar sulfuric acid solution. Okay. Solution, that's my abbreviation for solution. I don't know if that's the common one, but that's what I use. Needed to prepare 125 milliliters of a 0.100 molar solution. Okay, so how much of this really concentrated solution do we need to add to water to make a final solution of 0.1 molar at 125 mils? So these word problems, you really have to read them and use context clues to find which one is your initial and which one's your final. Okay, so you got to be really careful here. Okay, so I put the purple as our final, right? We want a 0.1 molar solution, and we want 125 mils of it. Okay, but to begin with, we have an 18.1 molar solution, and we don't know how much volume or how much of that solution we need to use, right? We're going to take a tiny bit of this really concentrated solution, and we're going to put it in a lot more water to water it down. Okay, does that kind of make sense? That process of diluting?
Very small.
Okay, so for our initial volume, we got 6.91 times 10 to the negative fourth. Okay, and that is in what unit? That's liters. Yeah, so if we put that into milliliters, it would be 0.69 milliliters. That's right.
How did I do it? Couldn't you just leave
You
it
probably-
in liters for your problem?
I just didn't know.
What'd you say?
Couldn't you just leave it in milliliters?
Yeah, you could leave it in milliliters for your problem. I switched this. This is liters. So that's why my other volume came out in liters.
Oh, okay.
This is liters right here.
That's liters, 125 is milliliters.
That is like two.
So I put it into liters to go into my equation. You could leave it in milliliters, which is fine. And that would give me 0.691 milliliters. Okay, so they're not even taking a full milliliter to dilute the solution. So 18.1 is really concentrated.